Okay, so this is lesson 7.2a in college algebra, and just wanted you to see a picture of where I am making this recording. I am in a place called Paradise Cove out in my boat while my wife and her friends are out kayaking. So I'm out here in the Alaska wilderness making videos and teaching college algebra. Doesn't get much better than that. Anyway, let's get rid of this and get moving along, since I'm sure you'd much rather do college algebra than hear me talk about what's going on. All right, so in the last section we had problems that looked like this. And remember, my z's have the line through them, whereas my 2's do not. So see, one's a 2 and one's a z. And 3x plus y minus z equals 9. Okay, so in the last section, when we were doing these, what we did is we tried to get the x to be a 1, and then we didn't care what the y was, and didn't care what the z was. And then we tried to get rid of the y, so nothing was there. And we wanted a 1 in front of this y, and then whatever our z was. And then in the third row, we wanted these two to go away and to have a z there. So these were 1, 1, 1 in a diagonal, and these were zeros. Tried to make those go away. Okay? In this lesson, one of the things, well, for one thing, we're going to do what's called matrices, or a matrix. And what we're doing is the exact same thing we did in 7.1 with this, only if you notice here, when we did all this work, all we dealt with were the numbers. The x, y's, and z's were just kind of along for the ride. We didn't really do anything with them. So when you have an array of numbers with just the numbers and not the variables, we call it a matrix. All right, so this problem here could be written just like this. Make a big bracket, or whatever you want to call it. 2, -3, a 1. Draw a line and write a -1. That line basically represents an equal sign. A 1, -1, a 2, and a -3. A 3, a 1, a -1, and a 9. Okay, so there's the exact same three equations without us writing the letters. And that's pretty much all we did. Okay, so this is called an augmented matrix. Augmented matrix. And it's called an augmented matrix because it has my equal with this vertical line here, and then my numbers right here. Okay. Anyway, this is called the augment of the matrix, and because it's in one matrix like this, it's called an augmented matrix. Okay. So it has a specific dimension, and this dimension is always labeled as your row. Oops, let me get my pen out here. Row times column. So how many rows are there? There's 3 rows and there's 4 columns. So this is called a 3 by 4 matrix. Okay, that's its dimension. If we only had 3 rows and 3 columns, it would be a 3 by 3 matrix. So in other words, if this disappeared, this would be a 3 by 3 matrix. And when the rows and the columns are the same, it's called a square matrix. Okay, so just some things there to give you some vocabulary on what's going on. And if we have, let me move this stuff up. If we have a matrix that looks like this, and let's say it's a 3 by 3, but it looks like this, that's called an identity matrix. Okay, so we've got a couple different types of matrices that we're going to look at. The first one is called an echelon form of matrices. All right, so let's get started on how to solve these. And one of the things that I want to remind you of is they're done the exact same way that you did the system of equations with 3 equations in 7.1. Done the exact same way. Nothing is different, only we don't have letters to deal with. All we have are the numbers. So let's do the first choice, or the first opportunity that they give us to kind of see what's going on here. My golden retriever is just sitting on the front of the boat, just laying down, sleeping, not bugging me, not wanting to go swimming, so that's good. Okay, so let's rewrite this as a matrix. So 1, -1, 2, -3, 0, because there isn't any numbers under the, or for the x. And we don't have an x or a y there. Okay, so what we have here is a matrix in what is called echelon form, because what has happened here is that we have our diagonals, and this diagonal has to all be 1s, positive 1s in fact. Everything to the left have to be 0s. Once it's in that form, it is called echelon form. Okay? Once it's in that form, notice what we've got. We found our z, they gave us our z already. Then we go up 1 and we plug -2 in here and we solve for y. Then after we solve for y, now we have what y equals and what z equals, and we put y here and the number for z here and solve for x. Okay, remember that's called back substitution. So that's how we find our x, our y, and our z. All right, so the rules for doing matrices is the same again like you did in 7.1. So let's go ahead and try example 1, and after that we'll look at another way to do matrices called the Gauss-Jordan method. So let's get rid of this and we'll type example 1 here. So I'm going to turn this off while I put that information on the screen. Okay, so there's the equation, the system of equations there that we're trying to solve for x, y, and z. And remember, we are trying to get our diagonal here to all be 1s, and then everything to the left to be 0s. Okay, so that's our goal here. All right, so let's go ahead and write the matrix out and just put the numbers out here. So 2, -3, 1, line, -1, end. So we have 1, -1, 2, -3, 3, 1, -1, and 9. Okay, so there we go. We don't even care about this anymore. Okay, well, at least for right now. We will need it later when we go and back substitute. Okay, so let's move this up. Okay, so there's our 3x4 matrix. And again, we are trying to get this to be a 1, this to be a positive 1, this to be a positive 1, this and this and this to all be 0s or to go away. Okay? And once that's done, we're in good shape. Okay, so we're going to do these just like, again, like we did the other ones. Now notice, we have a 1 here, and that needs to go here. So I'm going to switch this row with this row. So I've got 1, -1, 2, negative 3. And I'm going to put the 2, negative 3, 1, negative 1. I just switched those two around. Okay, so just like we did in the last one, once things are the way they should be, we lock them. Okay, so that one's locked. Now we're going to use that one in order to change some of these other ones around, but when we're done, that is the completed row there. All right, so for example, if we would like this number right here to be a positive 1, because this has to be a positive 1, positive 1, positive 1. If we want this to be a positive 1, we're going to have to do some stuff in order to make that so. If we want that to be a 0, we're going to have to do some stuff to make that work. So let's go ahead and make this a 0. So we can make this a 0 by multiplying this whole row by negative 2, because then this becomes a negative 2 plus 2 is 0. So let's multiply this top, and again it's locked, so it's not going to change, but let's go ahead and multiply the entire row by a negative 2. So we get negative 2, positive 2, negative 4, positive 6. Okay. Okay, and we're going to leave the second row alone. We're going to add those. So that becomes a 0, negative 1, negative 3, and a 5. Okay, so that second row has changed what it looks like. So let's go ahead and see what we've got here. We've got our first row, and our new second row, and our third row that we still haven't touched. Okay, so again, this row is the one that's locked, and we just changed the second row here. We got rid of that 2, and it now becomes this row right here. Okay, it's not locked yet because even though that's a 0, this has to turn into a positive 1. So what we're going to do to change that to a positive 1 is multiply that entire row by its opposite. So we're going to multiply that entire row by a negative 1, and then that negative times this negative will make that positive. So let's go ahead, and I know I write these over and over and over, but I get confused if I don't have everything written out. Okay, so I'm going to multiply this by negative 1. So that's 0. That becomes 1, positive 3, negative 5. And again, we did not do anything to the third row. Okay, so because both the first and second row are exactly what we need, let's lock those. Okay, and that leaves us with our bottom row here, where this needs to turn to a positive 1, this needs to go away, and that needs to go away. Okay, so the nice thing about this 1 up here, if this is the first number we change to a 1, then we can use this row over and over and over again to change the other rows. So if I multiply this row by negative 3, this becomes negative 3 plus 3, which is 0. So let's go ahead and multiply this locked row by negative 3. And that gives me that. And then I'm going to look at my third row. And I'm going to add those, and those go away. This becomes a 4, negative 7, and an 18. Okay, so that gives me a new third row. So let's go ahead again and rewrite my first row and my second row and my new third row. Okay, and again, I always like to highlight what's locked. Okay, so I know I'm done with those, and I also know that I've rewritten them correctly. I'm not letting any of my other work where I change things around in order to add them to another row mess me up. Okay, so third row, I've got a 0 here, I've got a 4 here, and I have a -7 here. This needs to be a 0. This needs to be a 1. So we keep going. How do I make that a 0? Well, if I add its opposite, that's going to give me a 0. Okay, so because I'm up to 16 minutes, I'm going to take a picture of the screen here, of this right here, because that's all we need. And I will start on a new video with just this picture that you see right here.